and performance. 300 rollouts gets you a bit more performance, but it does slow it down a bit. So if we wanted to absolutely squeeze out the most performance we could out of this, then probably the next steps for this would be to write in GPU acceleration. And the way that would work for something like this is it would basically take all of the really heavy, repetitive tasks like addition and stuff like that, and it's going to throw it onto your graphics card and say, hey, you go do this while I do the other things. And that'll, in most cases, increase performance dramatically. The initial tests I did, which I haven't gotten implemented yet, showed that it was like a 90% increase, like in time. Like it's insane. A task that could take minutes will just take a couple of seconds if you throw stuff on your GPU. But we are using a pretty nice GPU to begin with, so that's always something to consider. So yeah, we can see it in the play-by-play here. Also, we notice that normally it shouldn't play like this. Like it'll just play both moves at the same time, but we put a small delay between the moves just so it looks a little bit better to people, because people want to see it played like how they would play a game. And already we can kind of see that this is getting pretty significantly slower. The last game, the lower rollout level, we didn't have any games go over 30 seconds. Here we have already after the second game, or on the third game, we already have it approaching 40 seconds to a minute, and we'll probably have it be like a minute, upper minute for some of the other games. But yeah, it's not too apparent until you get to different higher levels here, but it can get pretty long, and there's probably not too much more performance to be squeezed out of this, since we're already anywhere from probably what was it, it was either upper 80s to upper 90s. It's between 100 and 300 rollouts, and 300 is kind of the sweet spot if you can afford the time to wait. One thing to notice here, if you look at the board right now, you can see that it's sort of learning to deny space by having a checkered pattern. That's because in the game of Grossthello, you can't place a piece such that it would be basically captured by an enemy, so white can't go in these spaces like right there. So by having a checkered pattern, we deny space to the enemy. This is something it's naturally figuring out on its own from the simulation process. And the way it works with this specific learner is a bit more complicated and wordy, but essentially a rollout is going to be a way that it trains itself to learn from the current state. So it's going to say, hey, where are we from here? Where is there to go? What route in this set of options I have yields me the highest percent of chance of winning. And this same machine learner that we're using right now is the same one that was used in the StarCraft AI that did really well. This obviously isn't anywhere near as complex, but it's a pretty powerful technique for games as applied to machine learning, because it is a lot faster than some of the slower and less, I'm not going to say less, the more bulky methods. It's quicker than the more bulky methods that don't explore just what it needs to. Here we see the time and performance complexity scale roughly to the size of the state space and the actions available. So it's a lot more efficient than just checking for every single possible thing. And if by chance anyone has happened to see this game before and knows of scores versus this specific Grossthello AI player, please do let me know. I'm pretty sure none of them are going to be higher than 95%, but it would be cool to know if there is, just so I can get a feel for comparison of how this works versus other AI techniques. Yeah, so we can already see our game time up to a minute. After we finish up these last couple of games, we will move and go look at the results we collected a little bit, just to show you that they're there. And then the last round is going to take a total of 8 minutes, roughly, a bit longer than that. Probably like 9-ish. Yeah, it's... Like I said, the times go up really fast, and this is only a really small example, so... The first trial we did took roughly 2 minutes, and that was the 100 rollouts, and this trial should take little over 4 minutes, and the next one's going to take 8-9. So you can see as we add on rollouts, things can quickly get really, really slow. But the good news is we're doing really, really well, even without all those extra rollouts. I think I might actually set this to run and go get a drink. Yeah, again, we can see the sort of learning strategy right here. This checkered pattern is really effective for controlling board space. And just a note about the game itself. So the game ends when there are no more spaces that can be played by anyone. And again, you cannot play a space as, you know, a color if it would deprive a group, if it would become a group with no liberties, which is kind of fancier talk for if you put a stone in there and it's going to be immediately surrounded, you can't put it in there. And if it's your same color and you put it in there and it would make a group with no extra spaces to go, then that also is forbidden. So that's why you see this game never ends with the full board. I don't think that's possible, which is why you will see like one or two couple of spaces that are always going to be empty. All right, we're finishing up our last trial here. That was nice. I managed to get the entire board. All right, so gonna move over here. We can, well, it's pretty small, so don't strain your eyes, but we can see there's a total of 200 rollouts. It played 10 games, and it won every game. This is, again, not too uncommon. And we can see the time for playing is going to steadily creep up. So if you look over here where it's bigger, we can see it starts at 40 seconds and sort of ends at a little over a minute. So now we can see the effects of, you know, the problem of having a lot of rollouts in here start to get a bit more apparent. And without further ado, we're going to move on to our final trial. This should take